Hey, hi everyone. Welcome to London's Calling. Myself, Vaishali Singh, been into Salesforce industry for last 9 years. It's been a privilege. It's been a wonderful journey. Working as a senior tech consultant for Deloitte. Um, and yeah, so um, today's topic, uh, afraid of large data volumes. Don't be. No need to worry about large data volumes if you have actually put your thoughts into uh, how to model your data and different strategies which could actually help you um, understand um, what's large data volume is. So moving on, today's okay, just a second. Yes, so today's content is definitely we are going to talk about what large data volume is, what are the known issues, then we are going to talk about multi-tenant architecture, some data model and data management considerations, and different kind of uh, tools so that we can handle large data volume and organize our uh, company system in a better way. So moving on, so what is LDV? So there is no one measurement that can say or can be used to determine whether an org is a large data volume or not. Both large and small orgs can be at an equal risk, but definitely the number of records which sits into the system can be a reliable uh, indicator to say that it's an org with large data volume. But even the way data is structured or architected in the system is also a, a way to determine whether it's a large data volume or not. So yes, so LDV, we can say that it's definitely not we cannot say just by looking at the number of records that it's a large data volume or not. Some of the large data volume issues like account data skew, ownership skew, lookup skew, record locking, sharing issues. So going one by one on these, what is account data skew? It means that a parent has more than 10,000 records. So just imagine your org, which has just 50,000 records in the system, and it's been poorly structured in a way that someone has associated a large number of children records to one parent record, more than 10,000 records. And then an org like this goes into a performance issue because something like an issue of account data skew might be happening in that org. The similar is ownership skew, where large users are owner of a single record. So um, when reparenting or assigning uh, this, like when we are doing a data load and uh, and associating large number of records to the single user, data load might fail because there would be an issue with the ownership, since single owner is assigned to a to large volume of data. Similar as lookup skew, and so you might have heard about record locking, wherein when we are actually loading lots of child record and to a single parent record. So after 10,000 records, what happens is the parent record gets locked because the children records are are still getting updated with the account information as a lookup, and that's something record locking. Sharing issues we have in orgs specific to where they have role hierarchies. Uh, Many a times sharing issues come when we are assigning or like restructuring the org or restructuring the role model, and the user has lots of uh, records underneath it. All the sharing calculations happen in the background when we are reparenting or reassigning them, and then that's leading to sharing issues. So these are some of the large data volume issues. So even an org with 10 or 15 million records can perform better if we have considered the way we should uh, uh, define our data model or structure our data model. So moving on, so um, why we have put these limits, why we have governor limits, why we have been talking about 10,000 records, we have been talking about concurrent users. If thousands of users are using Salesforce at the same time, then also it results into a performance issue. So we are talking here about numbers. The reason is we have something called as governor limits, which Salesforce has enforced, and that enforcement is definitely necessary because Salesforce is a multi-tenant architecture. So looking from the architecture perspective, how uh, so it's really very important to understand how the architecture is set up so that when we are creating our data model or designing a solution, we are more conscious. So let's have a look at this one. So when we think about an account object, so to us, it simply means an object or a class with a defined set of attributes. But how they are actually structured in a table in a Salesforce world. So we have metadata tables, which is objects fields. So if you look at the diagram, we have two different set of tables to actually store the objects, and like the object definition and the fields. And then these two actually is combined as a data table, data, where we have uh, which we call as a large heap storage for structured data of custom objects, and same goes with the standard objects. So if you look on these specialized pivot tables, we have different tables to structure different kind of fields. So if we are saying there are 2 or 3 indexed fields for an object, it's stored in a different table. If there are unique fields, they are stored in a different tables. Relationships, they are stored in a different table. Yep. So um, so the relationship, they are stored in a different table. So if we want to actually make a query or create a SOQL or run a list view or run a report, actually if we have fields from these different sets of unique tables, these are Salesforce has to actually make a join query to actually give us the information. So definitely, the more the table, the more the joins Salesforce has to make to actually give us the result, the poor the performance will be. So it's really important to understand how this database works and Salesforce. So we have a shared database, we have a data tables, and then that data tables is actually comprised of pivot tables and meta. So there are so many smaller tables which are actually involved. And if you want to make a query from a single object, it requires so much of interaction or calls to the tables, to different tables. So Salesforce has said, has mentioned about what are the keys to performance. So selectivity. The first thing is the amount of data which is accessed during a query. If we make our query selective, then definitely it adds to the performance. If we reduce the joins, as we spoke, there are so many joins required to actually fetch us the records. So if we reduce the joins, the performance will increase, and definitely lower the data, better the performance. But yeah, making sure that data is structured or is architected in a proper manner. So data reduction, less data. And the other way is Salesforce has so many archiving mechanism which can be used. Moving on, so what are the different data model considerations? Master details. So child records with more than 10K records can cause a lookup skew, which we have already spoken. So whenever you are creating or architecting your data model, make sure how many records this a parent is going to have, and then actually decide on creating the relationship. Saying the ownership causes problem when inserting records with single user or reassigning it to another user. Yeah, so this is the ownership issue. Junction object. Junction object is a great tool, is a great object which we have in Salesforce. But just imagine if we want to upload information about one object, we might end up adding information in two objects. So, and the other thing is both the master objects need to exist before we create or insert records in a junction object. So those considerations, be mindful when doing a data load, and when doing your data model architect. Talking about fields, lookup, quite simple, easy, uh, gives us lots of advantages, but again, it's actually a join to records. So again, if we have a lookup in an object, and if we are using that lookup in our search results, in our reports, we are actually making a join query to Salesforce database, and then that is something which adds to the performance. Formula feed looks easy, simple, a great out of the box way um, to make life easy. But that's again a SOQL function. Roll up summary, filter lookup. Yeah, some of the examples where it looks quite simple, but in the background, these are actually doing SOQL functions. SOQL functions may be doing joins and getting us the information. That that could be a risk to the performance. Cool. Moving on. So data management strategy. God gracious, Salesforce has provided so many data management strategies. We can use big objects. We can use master data management. We can use external objects. I'm sure you might have heard about external objects, like the system just exists in other system. If we don't need that information to sit in Salesforce, that's totally fine. We can just call our external objects. We can build reports on the external objects. We can display information at real time using external objects. It's one of the great ways of actually using uh, using the data which doesn't sit in Salesforce. So yeah, it's that's one way of managing your data. So how does a query optimizer works in Salesforce? So when you do a SOQL, when you do a report, when you do a list view, this is something which happens in the background. So sharing, indexing, and we have something called a skinny table. So customer does a query, it goes and look for OWD, whether it is public, private, then it goes for other, we have manual sharing, custom sharing, it does all the calculations and then say, okay, I've got like these many records for this particular logged in user. Out of 10 million records, this user has an access to maybe 20,000 records. Then it looks for, and if we are making any query or running a report or a list view, then it looks for indexing, whether we are using any indexed fields. So yeah, I'm gonna talk about indexing and skinny tables in a while. So, so yeah, and so it checks for indexing, and then it checks for if there is any skinny table which exists for this particular object or for this query, the query which is done on that object. Cool. So indexing, there are multiple things. We have index, sort optimization, or clauses, column index, two-column index, and clause. We are going to talk about it in the next slide. Moving on, skinny tables, a great tool, a great way. So if you remember about joins, which we talk about, skinny tables is just a single table, but just a single table which is created. We have to actually request Salesforce to get it created for us, which will have a limit to certain fields. And then when we actually make a query from the skinny tables, like a list view from that skinny table, run a list view or run a report from that using that skinny table, there won't be any more joins which will be involved, since all the fields, all the pivot tables will be a part of single skinny table. So it's most useful when an object has millions of records and you want an improved performance for reports and list views. Cool. Moving on, so few benefits. It do not include soft deleted rows. Platform automatically synchronizes the rows between the base object and skinny tables. And yeah, narrower the rows, less the data to scan. That means increased performance. Limitations, yes, it can add up to only 100 fields, and those fields must be of certain type. It cannot contain fields from other object. That means cross-reference of objects are not available, and it doesn't get copied over sandbox organizations. Query optimization. So let's have a look at how a query optimization works. Before going to this, so we have spoken about skinny tables, and so what's indexing? Index is something like searching a word in a dictionary. So you search a word in a dictionary, there are two ways. Either you can just go scan the word going through each page, or you just look at the end of the dictionary, get the index, and then yeah, it's quite not easy, but it's quite it doesn't take a lot of time. So the same way in Salesforce, the query optimizer works. So let's have a look. Index. So what is index? If we say index, it's like a field marked as unique, marked as external ID, or primary keys, foreign keys, and audit fields are automatically indexed by Salesforce. So if you're using these fields in your software, you're using it as a condition in your list view or in reports, then those fields are actually already indexed, and we'll see how an index field works, how it contributes to the performance. So how many records returned? So based on this, if these are in the where clause or in the filters, how many records returned? So we have a Salesforce has said there is a standard index, has defined a standard index for the total number of records returned. And so, sorry, and it has a different thresholds for custom index. So just it's quite a complex thing to understand right now, but these are few of the things which you can go back and have a look, and if there is question, just you can definitely reach out to me or any of your friends. And then that's it. So this is how a query optimization a query optimization works. So index selectivity exceptions. So even if the field is indexed, but if we have used a negative filter operator against that field, against that indexed field, it wouldn't be called as uh, the the field wouldn't be used for selectivity or for the optimization. So for some of them is not equal to, not like, excludes, or using comparison operator paired with text fields, leading wildcard. Many times we use name like or name equals wildcard, and then we put the string. So that's a no-no, because that wildcard is wouldn't be considered for selectivity, and definitely cross-object formula field. So these are no when you are creating your filters in a list view, or creating a filter for a report, or even in the SOQL queries. So is there a tool? So let's talk about is there a tool which could actually help us identify if my queries is optimized or not. So this is just an image of how a query plan tool looks like. So yes, the answer to that is query plan. Yes, Salesforce provides query plan tool. Just providing a bit small. So cardinality is the total number of records returned. Fields, the field which we have used as a where clause in our query, and we have leading operation type. There is a table scan and there is an index scan. Cost. So bear in mind, cost should always be less than 1 to be considered as effective for indexing and an optimized query. So let's have a quick demo on how this query plan works and how the performance, and let's look how the performance is there. Cool. So a short video on how to enable the query plan tool. Go to help, preferences, enable query plan. That's it. That's all you have to do to enable query plan. Let's have a quick example on execute. So created date is an index field. When we run a query plan, we get 2 costs because created date has been added as a where clause, which is making it selective. So if you look at the cost, cardinality is 40, cost is less than 1. It's quite less than a full table scan. So full table scan is nothing but looking for that word in the dictionary, page by page. So the next one, we have added field, which is error. So table scan is more efficient than an indexed scan, if you look at it. So even if it's indexed, it's of not use. So yes, that's the way you can just go ahead and check it out. So other example is we have a created date and is error. So we have added 2 where clause, and if you look at the index, It's quite less. Cardinality is 7. It means that it will just return 7 records out of 21,156 records. It's indexed and cost is quite less. The leading wildcard operation, yes, like leading null. Look at the table scan, 0.6x, index is 0.014, which is quite less. Yes. Okay. So if that has made sense, this is a great tool. I have used this tool a lot of time when working through my projects with large data volume, doing batch jobs where they might where we wanted to process a lot of data and there were issues with the query. So yeah, it's a great tool. Go just for your interest, just go ahead and play with this tool. You will be amazed in how it works. And yeah. So yeah, that's I guess that's all from my side. Sorry, I won't be able to do Q&A because this is the recording which we are doing. But yes, I have my Twitter account. You can just go ahead and post me any question. Yeah, thank you so much for listening and take care. Thank you.
Blockchain can help feed more people. And AI can help care for people. VR can help train people. Let's use technology for people to make a greater good in every community, every day. Accenture. New applied now.